In this video, we will be looking at question 6 and question 7 from the workbook. So let's jump in. It says the diagram below shows the graph of that, and we immediately, grade 10s, need to be able to identify that as an exponential. Our x is part of the exponent. And then we've got that one over there, which we must immediately be able to recognize as an hyperbola, since the x is part of the denominator of that fraction. And then they just added a little bit of information. For the hyperbola, it's where x is only bigger than 1, bigger than 0. So x can only be the positive values. Now, don't be confused by that. Normally, our hyperbola just has its two curves. Say, like there's curve 1 and there's curve 2 for the same hyperbola. Now, in this case, they're just saying we're only going to look at where the x values are positive, so we only are looking at that part of the curve. That's all they're just kind of adding over there. All right, and I mean, when we look at the graph, we can see that only the one part of the hyperbola is there. Then it says that the point E, which is where x is 2 and y is 9, there it is, lies on the graph of f and g. So it is a point on both. It's always handy to have a point that's on both. Let's quickly investigate before we even look at the questions. Well, what jumps out at me there is I can see that I've got the equation of my asymptote over there is given, and that needs to mean something to us. We need to know how we're going to use that. What else? We've got an y-intercept over there for our exponential. We've got the 1 point that both of those share. Yeah, I don't think there's much more to it. Maybe you see something else. Let's look at the questions. It says that we need to determine the values of a and q. So basically they are asking us to find the equations for the hyperbola, a over x plus q. All right, what information can we use? Well, we need to know that that gives us our horizontal asymptote. So we can plug that in there. It is given on the sketch. So we know, so far we've got a over x and then plus 2 that we read just from the diagram. So now we've got one missing thing that we need to find. And luckily we've got a point that we can plug in. We've got a point that is on that hyperbola, the point 2 and 9. So if we plug in that point in the place of y, in the place of x, and now we can just solve that. So if we take the 2 over, this is just now an equation that we can solve, right? So if I subtract a 2 on this side to make that go away, I must just do it on the other side as well, which would then give me 7 is equal to a over 2. And then to get my a by itself, we are after a, I'm going to multiply this side by 2, because when I do that, that happens, but as long as I do that on the other side as well. So then we get that a is equal to 14. So therefore we found the equation for the hyperbola. We found a, we found q, so the equation of g of x is 14 over x and then plus 2. That's it. First one done. Second one. For which values of x? So our answer needs to be x is this or x is that or whatever. They want the x values where this is true. All right, let's take our time with this one. There we've got 6.1. Here we've got 6.2. It is worth it to spend your time on this. It's not always going to take this long and this much time. Just as soon as you get used to it, it would go a lot quicker once you get the hang of it. All right, they are saying we need to look at that. Where f of x is smaller than g of x. Let's write that in words. What are they talking about? They are talking about the y values of f is the exponential, right? They're talking about where are the y values of the exponential smaller than the y values of the hyperbola. So we can also say with smaller than, we can say where are the y values of the exponential. If it is smaller than the y values of the hyperbola, it would be where the exponential graph is below the hyperbola. So let's go highlight those parts of the graph where that is true and then we're going to state those x values. Let's go ahead and do that. Where is the exponential curve below the hyperbola? Well, there's my exponential over here. It is below my hyperbola there. Oh my gosh. And then there by E, it changes. From that point, let me just highlight that in a different color. From that point on, from where x is 2, there my exponential would be above and my hyperbola would be below. But remember, we want where the exponential is below the hyperbola. All right, so let's go flag those x values. So that is true. All the way there, remember that carries on with an arrow all the way to where x is equal to 2. So how can we write that? It's either that x must be smaller than 2. 2 is not included because it's not included in the question. We can also write it as x is an element of starting from negative infinity, round bracket, to 2. There we go. So between those x values, for all those x values, the y values of the exponential would be below the y values of the hyperbola. Yo, these lines of mine is terrible. Next one. Calculate the value or values of x. So again, our answer needs to be x is this or x is that, for which that is true. Now let's just make sense of that. It's okay when we look at something like that and we're like, what? So 6.3 says that 3 times f of x gives me 9. Remember, this also just represents a y value. So 3 times the y value of x, of f of x, must give me 9. Let's see if it will work when we just plug in there what f of x is equal to. So 3 times, we've got the equation for f of x. It is 3 to the power of x. That is our exponential. And that will be equal to 9. So I just plugged in there. I took f of x and I'm multiplying it by 3, like they said. And they said that that would be equal to 9. So I'm just creating that equation that I can solve. This is now exponential equation knowledge. Not just one way that we can do that. So since we have a normal 3 on the left, and what do I mean by normal 3? I just mean that that 3 over there doesn't have an exponent like a 2 or an x or whatever. It's just a normal 3. So that means we would be able to divide both sides by 3. Then we are left with that. And remember, with our exponential equations, if our bases are the same, our exponents must be the same. So calculate the value or values of x where that is true. And that is the x value where that is true. And that's it for question 3. Okay, question 7. Sketch the graph of that. We immediately, grade 10s must be able to identify that as an exponential function because the x is part of the exponent. And then also of g of x, where that would be a parabola. How do we know that? Because our x is being squared. Okay, we need to draw that on the same set of axes. We can do that. And it says that we clearly need to show the coordinates of the turning points. And note, we need to put it in coordinate form. And all the intercepts with the axes. So that would include our y-intercepts and our x-intercepts. All right, let's go ahead and do that. Let's start with the parabola. 3x squared, take away 12. That needs to mean something to us. We need to know that that's the A, and we need to know that that is the Q. We need to know that that gives us a happy face parabola, and we need to know that that will have a turning point by negative 12. So I'm just going to use these by 2. 2, 4, 6, 8, 10, 12. So that would be negative 12 over there. So one block is 2 units. And it will be a happy face, so we know that it will be something like this, and there will be x-intercepts. How do we find x-intercepts? We're going to make our y0 like with all our other functions. So if we make y0 there, you can decide how you're going to solve that, if you're going to use factorization or not. So what I'll do is I'll just do that. I think most of you would do that anyway. And then I'm going to divide both sides by 3. Then I'll end up with that. And then if we get the square root on both sides, then I get that x is equal to plus or minus 2. So for my x-axis, this is actually illegal what I'm doing, but for my x-axis, I will still make 1 unit. No, actually, I'm not going to do that. So since for the y-axis, we used 1 block as 2 units, we're going to do the same one for this one. So it's going to be a very narrow parabola. Oh my gosh, this is going to be terrible. Let me try my best. So there we go. It cuts there. It turns there. It cuts there. And there is my parabola. You know what? I'm just going to give it one more bash. I've given up to get them perfect with my free hand on my computer. Okay. Please don't use this as an excuse that yours can also be ugly. Make yours pretty. Okay, there is my parabola. I'm going to put in the coordinates like they asked. So I must put that one in as 2 and 0. And that one would be negative 2 and 0. And that one would be by 0 and minus 12. So they are the intercepts with the axes for my parabola. And I am putting that in. That is my g of x. Okay, there's our first curve. Now we are on to f of x, which is our exponential. There's so much that we need to remember with an exponential. So if we think about our standard form, I'm just quickly going to write that down. Y is equal to a times bx plus q. There we have our q, which gives us our horizontal asymptote. So I'm going to go put that in straight away. Let me just get a different color for that. Okay. So that would be by 1. So in this case, it will be in between because remember, we chose 1 block as 2 units. So there is our asymptote. Use your ruler. And then our a value is 1 in front. So it is a positive, meaning that our curve will be above the asymptote. And then we have that our b value is 2. And remember, when our b value is bigger than 1, the graph will increase like that. And when our graph is a fraction, it would decrease. All right, so we know that this would be an increasing function like that because our b is equal to 2. Okay, so what shall we do to go plot that? We put in our asymptote. That is perfectly fine. Let's go find our y-intercept. Will there be an x-intercept for this one? The whole graph moved up, and it's going to be above the asymptote there, so there won't be any x-intercepts for this graph. So let's go find the y-intercept and then decide what other points we're also going to go plot. So to find the y-intercept, we're going to go make our x equal to 0. So when we make x 0, we're going to land up with that. And that will just become 1. So our y would be equal to 2. So that means when we made our x equal to 0, our y is 2. And that gives us our y-intercept, which will be right there. Now let's just go plot 2 more points, shall we? Let's just use a table. You don't have to put it in a table if you don't want to. But let's just choose 2 more values for x, 1 positive and 1 negative. 1 positive so that we can get a point on this side, and then 1 negative so that we can get another point on that side. And I think we should substitute in for x, shall we just plug in 2? And then for a negative, let's plug in negative 2. All right, so when we do that, what will our y be when our x is positive 2? That will give us 5. So when my x is 2, my y is 5. Let's go plot that. When my x is 2, my y is 1, 2, 3, 4, 5 up there. And then let's plug in when our x is negative 2. So when my x is negative 2 plus 1, you can obviously just do that on your calculator, but that is going to give me, I believe it is 5 over 4. I don't have my calculator close, so if I make that exponent positive, it would give me 1 over 2 squared, which is 1 over 4. And if I add 1 to that, yeah, that should be 5 over 4. Okay, and so there's another point that we can plot. There's another point that we can plot by where x is minus 2, my y would be, well, that's just like 1 1/4. Our asymptote is by 1, so 1 1/4, so it would literally be like that. And there is our curve for our exponential, and there goes another free hand. There it goes. It will never touch the asymptote, and it starts to increase, and there we go. Put my arrows in, and like they asked, I'm going to go put my point for my y-intercept, which is by 0 and 2. And there we go. I believe we indicated everything that they asked, and I'm sure your curves are looking much better than this. Well done. Okay, now we're going to ask some or answer some questions about these. I'm sure. Let's see what they're going to ask us. Does the graph of G, there it is, have a minimum or a maximum value? And what is that value? So we're going to go look at the turning point of G. So G is over there. So it has a minimum, and it is by negative 12. It is where y is equal to negative 12. That is the minimum value for our parabola. 7.2. Use the graph to find the values of x. Everybody's favorite questions. So we need to find the x value. So our answer is going to be x is this or x is that. And we're going to read off the graph. Let me just move it up a little bit. Where? Okay, so first one, we're going to focus on a g of x. Which one is that? That is the parabola, yeah. So for the first one, we're going to look at the parabola, and let's just put that into words. So they are asking, where are the y values of the parabola? Because the g of x is just notation for y, right? So they're asking, where are the y values of the parabola? And bigger than 0 means positive. So where are the y values of the parabola positive? So we're going to go to the diagram or our sketch, and we are going to highlight where the parabola has got positive y values. Well, the parabola has got positive y values there, up to there, and the parabola has got also positive y values there. That's it. So now we need to write down those x values. So for 7.2a, it is where x is smaller than negative 2 because it changes at that point, right? Anything below that, my y values are negative. And I'm not including the negative 2 because it wasn't included in my question. 0 wasn't included in my question. And it's that x is smaller than negative 2 or x is bigger than 2 because it changes there, where x is bigger than 2. That's not just the only way that you can write it, grade 10s. You can use whatever way works for you. It must just say the same. Let's look at B. It says that, look where f of x, now f of x being our exponential. So where is f of x smaller than negative 2? They want the x values where f of x is smaller than 2. So let's write that with some words, kind of half words, but yeah. Where are the y values of the exponential smaller or equal to 2? Okay, I'm just going to write that. Smaller or equal to 2. So we are going to go find that on our graph where that is smaller than 2. So if I identify that y value of 2 for the exponential, it is right over there. So where are the y values of the exponential smaller or equal to 2? It is that part of the graph that we are looking at. Now we just need to go write down those x values for our answers or our answer. It is where x is smaller or equal to 0, because think about what is x there, where it changes. X is 0 over there. So all those x values over there is part of our solution. Why am I including it? Because it was also included in the question. 7.3. Find the equation of the reflection of f in the x-axis. We can do that. Which one is f? Is f the exponential? Can't remember. F is the exponential, all right? So what was the equation for the exponential again? 2x plus 1. F of x is equal to 2 to the power of x plus 1. They are saying that we need to write down the equation for a different graph when f is reflected in the x-axis. What does it mean when we are reflecting about the x-axis or in the x-axis? It means that the x-axis is our mirror. So if our graph is there and we have got an asymptote there, and this is our mirror, then it means that the asymptote that is there, let's say it's 1 unit from the mirror, then our asymptote will now be 1 unit on the other side of the mirror. And for our curve, if our curve is that side of the asymptote, it will be a reflection on this side of our mirror. That is how the reflection would look like. A rough sketch of what the reflection would look like. But now they want us to go give the equation. What's another way that we can go look at it? We can say that all the y values that were positive, all those y values will now be negative. So all the y values, so we basically take, in order to get, let's call it h of x. In order to find h of x, we need to take f of x and we need to multiply it by a negative. All the y values that used to be positive will now be negative, and all the values that used to be negative will now be positive. So therefore, h of x is equal to, if we take the equation of f of x and we multiply it by a negative 1. When we do that, we get that h of x is equal to negative 2 to the power of x minus 1. Let's see if it works. Let's see if it lines up with our rough sketch where we said our reflection is going to be. So that was our curve that is drawn that we're working with. We said our reflection is the one at the bottom. So this one over here has a y-intercept of 2, and the asymptote is by 1. And our reflection now has an asymptote by minus 1. Yes, it lines up. It's just on the other side. And then this is very important. So over here, we've got a positive a value, which means that our curve would be above the asymptote. And now our reflection for h of x that we worked out algebraically over there by multiplying the negative n now has a negative 1 asymptote over there, which means that the curve will be below the asymptote. So it lines up and we are definitely correct. I hope you find this helpful. These questions are not simple, and I hope that they're getting better. And I want to encourage you, if you haven't done so already, get the workbook, complete this section, go back to your textbook, look for more questions on this. I know that you will get better at this if you invest the time, and if you get stuck, ask for help.